Hello, this is Dr.Hanaa Assil, and this is Chapter 1 from Edexcel Chemistry O-Level, and we're starting with the first chapter, and this is states of matter, solids, liquids, and gases. Remember that you should have done this before somewhere. In solids, liquids, and gases have different arrangement of particles, and the particles move in different ways. And you should remember that particles are always moving, so we never say that particles are not moving. So what you will be required to explain is the arrangement of particles in a solid and the movement of particles in a solid and a liquid and a gas. So let's talk about arrangement of particles in a solid. As you see from the diagram, you should remember that solid particles are arranged in regular rows, close packed. Close packed means they're very near to each other. For a liquid, the arrangement of particles are, we always say, near to each other in clusters. Clusters means they are in groups somewhere. So at some point they're touching each other, some point they are not touching each other, but they are sort of near to each other. For gases, the particles are far apart and in a random arrangement. So when you're explaining arrangement, you have to tell me, is it some sort of regular arrangement or not, and how far or how near the particles are. Then, when we talk about movement of particles, we say that particles in a solid vibrate in fixed position. Remember, we never say they don't move. And we always say, don't mention the size of the particles because there is no difference in size between solids, liquids, and gases. So when something, a specific substance, changes from solid to liquid to gas, the size of the particles do not change, but they do change in the movement and in the arrangement. So movement of particles in a liquid. How do particles move in a liquid? They move around each other in a fixed volume. When we talk about gases, the particles move in fast, free, random motion. Okay? So, which ones are compressible? You should realize that the word compressible means I can press the particles nearer to each other. In order to press the particles nearer to each other, they must be originally far apart. So the one that is compressible is which one? Is the gas, because the particles are originally far apart. Now, which one has a fixed volume? You should realize that both solid and liquid have fixed volumes. A gas, of course, changes its volume according to the volume of the container. Now, which one has a fixed shape? We say only the solids have a fixed shape because liquids and gases take the shape of the container. Are we okay so far? So, change of state. When we change from solid to liquid to gas, you should remember that we need to heat it in order to change from solid to liquid to gas. If we're going the other way, you need to cool the gas to become a liquid, and you need to cool the liquid to become a solid. So when you heat a solid, it becomes a liquid. That is called what? It's called melting. So if I say what is meant by melting, melting is the change of state from solid to liquid. And this happens at a specific temperature. So the temperature at which this melting happens is called the melting point or the melting temperature. So remember that when you're defining the meaning of melting point is the temperature, not the point, is the temperature at which what? At which solid changes to liquid. Don't say at which a solid melts, for example. You have to define what is meant by melting point. It is the temperature at which solid changes to liquid. Okay, so from solid to liquid, it's melting. From liquid to gas, it's what? It's boiling or evaporation. What is the difference between boiling and evaporation? You should know that boiling is the change of state from liquid to gas, but at a fixed temperature, at a specific temperature. But if liquid is changing to gas at any temperature, that is called evaporation. So evaporation is the change from liquid to gas at any temperature. And another difference is that boiling happens all through the liquid, but evaporation happens only on the surface of the liquid. Okay? What if we're going the other way around? When we cool a gas and it becomes a liquid, that is condensation. So condensation is the change of state from gas to liquid. Of course, if I say what is condensation point, how would you define that? Condensation point is the temperature at which a gas changes to liquid. Freezing is the change from liquid to solid. What about from solid to gas? From solid to gas, it's called sublimation. So sublimation is the change from solid to gas or the other way around, from gas to solid. Both of these are called sublimation, and this is something that happens for some substances. Some substances, when they're solid and you heat them, they go straight to gas and they don't go through a liquid state. So let's take a look at a typical question. So a question like this says, what is X and what is Y and what is Z? So where is X? And take note of the arrow. Where is the arrow going? The arrow is going from liquid to gas. Yeah, that is boiling. From gas to liquid, condensation. From liquid to solid, freezing. Okay? The diagram shows a kettle of boiling water. As the water vapor cools, it turns into droplets of liquid water. The change of state when water vapor changes into liquid is called what? You should realize that it is called condensation. From vapor to liquid, the answer is condensation. Okay, you will be required to explain what happens during melting or what happens during boiling. Remember that melting and boiling, you're doing the same thing. You're heating the particles. And you should know that when the substance is heated, particles gain kinetic energy, move faster, overcome the attraction forces between them, and move further apart. So they're either moving from solid to liquid or from liquid to gas. What happens the other way around? What happens during condensing or during freezing? In that case, we are cooling. And when the substance is cooled, the particles do what? Particles lose kinetic energy, move slower, come nearer to each other. Okay? Okay. In some questions, you will be given the melting point and boiling point of something, and you will be required to state whether it is a solid at room temperature or a liquid at room temperature or a gas at room temperature. If something is a solid, you should realize that if it's a solid at room temperature, then it has not reached its melting point, and that means that its melting point and its boiling point are higher than the room temperature or whatever temperature you're considering. Now, if something is a liquid, that means it has already melted. And that means the melting point is lower than room temperature, but the boiling point is higher, so it hasn't boiled yet and hasn't changed to gas. If something is a gas at room temperature, that means it has already melted, it has already boiled, so the melting point and the boiling point are below room temperature. Are we okay with all of this? What is diffusion? Okay, you should realize that diffusion is movement of particles from an area of high concentration to an area of low concentration down the concentration gradient. That is the definition of diffusion. That means that if I put a particle of potassium permanganate in a beaker of water, the potassium permanganate is something that has a purple color. So the place where the particle is, that is an area of high concentration where we have lots of potassium permanganate particles. Now, the other side of the water in the beaker has very, very low amounts of potassium permanganate, so we say that is an area of low concentration. The gradual change in concentration from the area of high concentration to area of low concentration is called the concentration gradient. So the particles move from area of high concentration to area of low concentration until what? Until the particles are equally distributed all throughout the water. We can have diffusion of solids and liquids, as we had for the potassium permanganate. We can also have diffusion of particles of gas or liquid through a gas. Remember that you cannot have diffusion through solids. No diffusion through solids. So if I have some bromine, and you should know that bromine is a reddish brown liquid, and I cover it with another jar and I remove that cover in between, what will happen? The particles of bromine will first of all change from liquid to gas. So what makes it change from liquid to gas? The fact that the particles gain kinetic energy, move faster, overcome the attraction forces between them, and then move from an area of high concentration to an area of low concentration, and that is by diffusion. So that is your explanation of what is happening. You can also have diffusion of liquid in liquid. Okay, this is a typical question on diffusion where he has open-ended tube. On one end we have cotton wool that has ammonia, NH3 is ammonia, and on the other side we have a cotton wool that has HCl, hydrochloric acid. The particles of the ammonia will start to move from where there is lots to where there is less, so from area of high concentration to area of low concentration. The HCl particles will move from area of high concentration to area of low concentration. Now, if they're moving at the same rate, theoretically, they should meet in the middle, but actually they do not meet in the middle. They meet near to the HCl, and when the ammonia meets with the HCl, it forms a white cloud of ammonium chloride, and we find that this white cloud is nearer to the HCl. What does that tell you? Which one is diffusing faster? If we meet nearer to the HCl, that means the HCl particles are moving slowly, and it is the ammonia particles that are moving faster. And if we say why the ammonia particles are moving faster, because if we sit down and calculate the molecular mass, if you remember how we calculate molecular mass, nitrogen from the periodic table, the mass is 14, hydrogen, each of them is 1, so 14 plus 3, that's 17. So the molecular mass of ammonia is 17, while the molecular mass of HCl, the Cl alone, is 35.5. So that means that the ammonia particles are lighter, lower molecular mass, so they diffuse faster. So what affects the rate of diffusion? The main thing is the mass of the particles. The particles that are lighter, lower molecular mass will diffuse faster. Another factor is the energy or the amount of heat or the temperature. So if you put these gases at a higher temperature, for example, if I hold the tube with my hand, then the temperature of the body will heat up the gases. At higher temperature, the particles gain more kinetic energy, move faster, so they would diffuse faster. And you will find the white cloud of ammonium chloride forming faster. Another factor that affects the rate is the nature of the medium. So if we're diffusing through gases, then the particles will diffuse faster than if we're diffusing through liquids. Are we okay with this? So this was the first lesson in the IGCSE Edexcel Chemistry. The next lesson will be questions on these. So your homework would be to do the questions that are uploaded on the website in PDF. Download it, do the questions, and the next lesson we will discuss what is correct and what is wrong in your answers. Thank you for listening.